Okay, let's take one more concept here. Dithering. So here's a picture with 8 bits per pixel, 7 bits per pixel, 6 bits per pixel. Still looks good. I didn't need all those bits. So that's one reason that we're using 24-bit color, because at 8 bits per color channel, it's enough. I'm still looking okay at only 64 levels per color channel. When we get to 5, some of you can start to see the banding here. I don't know what Zoom's doing to you, so let me go a little bit lower where I know you're going to see it. Okay, now we're down to 3 bits per pixel. I only have 8 grays. You should definitely be seeing weird banding around this that you didn't see on the others. And then obviously, if I go all the way down to only I've got 4 gray levels, or I'm black and white only, 2 different gray levels, obviously this is not a color picture anymore. What am I going to do if my device only has black and white? I told you DLPs only have black and white. And in fact, your printer only has black and white, if you think about a laser printer, a black and white laser printer. But we can still get grayscale colors. How does that work? Skip the question, because we're getting close, and I'm going to give some answers here. We're going to turn things on and off rapidly. So if I want to show a gray, I'm going to make that up out of black and white pixels. And so these black and white, they're not quite pixels, but anyway, but we'll call them pixels, I guess. We're going to have black and white pixels, and we're going to turn on the right fraction of them to make the right gray. Now here, the dot sizes are actually changing, and this is what happened on old photographic film, and it's what happens in your laser printer. In certain other cases where we have fixed size pixels, we can't be changing the size of the dots, so then we're going to do it by the fraction of pixels turned on. So that's more like this kind of method. So this was an ordered dither. We'll see a little bit more about that. Here's a diffusion dither. It's a different way to calculate which pixels are on. But if I want a darker gray, I have less white pixels. If I want a lighter gray, I have more white pixels. Because remember, I'm limited to black and white. So when you print a grayscale or color things out of your printer, this is what's happening if you zoom in and take a look. Right? There's not a gray print from your printer. There's a how much black and white do we have covered. And this concept applies instead of in space, in time, when we deal with DLP displays. Here's some more examples. This is called a blue noise dither. Here's a bare dither. There's thousands of patents on different ways to do dithers. This is a particular kind. This is a diffusion, this Floyd-Steinberg. Anyway, they produce different kinds of looks if you can see the pixels. But the idea is if you do it with tiny little pixels, you're not supposed to be seeing it at all. Let me say just a little bit of word about this. In the ordered dither, you have to decide like which of these little pixels do I want to turn on. Here's a simple way that you might do it. You would make a macro pixel, right? And we'll call these things the subpixels. And each subpixel can only be black or white, but my macro pixel can have 16 gray levels, right? By either turning on 1 black or turning on 13 blacks. But which ones are we going to turn on? We're going to make some kind of grid pattern like this, and we're going to compare, like if we want this overall thing to be at level 14, then we're going to turn on all the pixels which have a number less than 14, right? And so it's going to create some kind of pattern. So we can put different kinds of patterns here, but we're going to have some method to decide which ones to turn on, and it creates different looks. Here's color. This is in a print magazine. This is way zoomed in on the print. We have different size dots, and we have our CMY, cyan, magenta, yellow. And here it is zoomed out a little bit less, right? This is what you might see in a magazine. So we do this in color also in this dithering.